7 ಗಂಟೆಗೆ ಒಂದು ತಗೊಂಡೋದ್ವಲ್ಲ 2:20 Hello everyone, am I audible to you?
Yes, sir.
Okay, so we will wait for a few minutes more. Let others join. Then we will start at 7:10 or 15 like that. And my screen is my screen is visible. I have shared a presentation.
Yes, sir.
Okay, so wait for a few minutes. Then we will start. Let others join. Hello everyone, a very good evening to all. My slide is visible to all of you.
Yes, sir.
Yes, sir.
Okay, so let's start. Myself, Vivekananda Naik. I welcome you to this third interaction session on atomic and molecular physics. I'm a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So let's start with the first problem of the day. So uh, this problem says, according to Wien's law, where the notations have their usual meaning, which of the options will be correct? Option A is lambda m divided by t square is constant. Lambda m by t is constant. T by lambda m is constant. And option D is t into lambda m is constant. So which one will the correct option?
Option D.
Yes. So Wien's law, basically this is based on
Sure.
blackbody radiation curve. So when we are plotting the blackbody radiation curve, can you say me which quantity is plotted
Me.
along x-axis and which quantity is plotted along y-axis? Yes. Yes, someone was saying something. Yes. So if you see in blackbody radiation curve, when we plot a blackbody radiation curve, so suppose this is the blackbody radiation curve. In x-axis, x-axis, one minute. Sorry, there is some issue with this pen. Let me solve it. So yes, now we are good to go. So we are talking about blackbody radiation curve. So in case of blackbody radiation, the quantity which is plotted along x-axis is either wavelength lambda or the frequency nu, and similarly corresponding to wavelength lambda, we have this power density. We call it as lambda u nu. So these are the two quantities we plot. I request everyone to mute themselves. So if you see, now let's plot with respect to lambda only, because in both the cases, so let's plot with respect to lambda only. So let's assume that we are plotting with respect to only lambda. So it will be u lambda. Then the curve will be somewhat like this. So it will be somewhat like this. Suppose this is for temperature 1, T1. Then if we plot another curve for another temperature T2, which is greater than T1, then the curve will be somewhat like this. So if you see the maximum, so this is, suppose this is T2. Then if another curve we are plotting at another temperature T3, then it will be around this. So this is T3, where T1 is less than T2 is less than T3. So if you see here, lambda m corresponds to the value of the wavelength corresponding to which there is maximum value of this u lambda. So here if you see, this is the maximum value of u lambda. This is lambda m1, we can say. Here the maximum value is lambda m2. Similarly, here the maximum value is lambda m3. So if you see with respect to temperature, when the temperature is increasing, the value of wavelength which corresponds to maximum emissive power or power density decreases. So this is basically Wien's law. So according to Wien's law, lambda m is inversely proportional to temperature. So with increase in temperature, the lambda m value decreases. So if you introduce the proportionality constant, it will be lambda m into T equals to constant, and this constant is known as Wien's constant. Can anyone tell me what is the value of Wien's constant? Yes, anyone? So the value of this constant is 2.879 into 10 to the power minus 3. What will be the unit? Yes.
Kelvin.
Once again, I couldn't hear you.
Meter Kelvin.
Yes, exactly. So the unit will be meter into Kelvin, because here it is lambda into T. So the unit will be in meter into Kelvin. So the correct option will be option D, where option D says into lambda m is equal to constant. So lambda m is the value of wavelength corresponding to which there is maximum emissive power or power density, and T is the temperature. So if we go on increasing the temperature, the value of lambda will decrease. So the Wien's law is lambda m into T equals to constant. So is it clear to all of you? So I will ask you one more question. Suppose I will ask you what will be the relationship between, suppose there are 4 graphs. This is option A, this is option B, this is option C, this is option D. So there are 4 graphs in one graph. So all graph between T and lambda m, it is based on this Wien's law only. So one graph is like this. Another graph is like this. The third one is lambda m and T. One is like this. And the fourth one is like this. Lambda m and T. So can anyone tell me, according to Wien's law, what will be the relationship between, which graph denotes the relationship between lambda m and T? Yes, anyone? So if you see here,
Option
yes,
C.
yes, thank you. That is the correct answer, option C, because option C gives the relation of lambda D is lambda m is inversely proportional to T. So this option is lambda m is inversely proportional to T. This is lambda m is directly proportional to T, and this is some arbitrary function. This is lambda m equal to exponential of T. We can say that exponential of T. So if you see here, the correct option according to Wien's law will be option C, because option C denotes the relationship, the correct relationship between lambda m and the temperature. So let's go to the next question. So this question is again based on another law which is related to the black body radiation curve. So the question says a black body is at 500 Kelvin. It emits energy at a rate which is proportional to 500, 500 square, 500 raised to the power 4, and 500 square root of 500, 500 raised to the power half. So which one of these will be correct? If a black body is at 500 Kelvin and it is emitting energy at a rate, so that energy rate will be proportional to which one will be the correct option? So can anyone of you tell me which law basically gives us the energy rate
E
and the
equal to
relation between? Yes, once again.
E equal to HB.
No, that's not. I am saying the relationship between the emitted energy rate and the temperature, which laws gives the same. So this is known as basically Stephen's law. And according to Stephen's law, the energy radiated per unit area per unit time is directly proportional to the temperature power fourth. So according to Stephen's law, this is Stephen's law. According to Stephen's law, the energy, the rate of emission of energy, that is energy radiated per unit area per unit time, is directly proportional to the temperature power 4. So here, since the temperature is given as 500 Kelvin, so the correct option will be C, which is 500 to the power 4. Is this clear to all of you?
Yes, sir.
So if you here introduce the proportionality constant like similarly to the previous case, it will be sigma T to the power 4, where this sigma is known as Stephen's constant. Stephen's constant. And can anyone tell me what is the value of this Stephen constant? And what will be the unit? So the value of Stephen's constant is 5.670, 5.670 into 10 to the power minus 8. If you see here, it is t to the power 4. So when it goes to the left hand side, it will be to the power minus 4. So in unit, it will be Kelvin to the power minus 4. And this E, what is this E? This E is the rate of emission of energy, that is energy per unit time per unit area. So energy per unit time is power and the unit of power is watt. So watt into per unit area, so will be meter minus 2. So the Stephen's value of the Stephen's constant is sigma equals to 5.670 into 10 to the power minus 8 watt into meter minus 2 and Kelvin minus 4. So this is the Stephen's constant and the Stephen's law. So this Stephen's law also gives the area of this curve. So if you see this curve, that's why with increasing temperature, the area under the curve is increasing, because if you see, according to Stephen's law, the total energy radiated, if you see the total area under the curve, then it will give us a total energy emitted, and that will be depending upon the temperature. So as the temperature goes on increasing, total radiated energy will increase. So the area under the curve will increase. So here the correct option will be option C. So the rate of energy transfer per unit time per unit area is directly proportional to the fourth power of the temperature of that black body. Is this clear to all of you?
Yes, sir.
Okay, so let's go to the next question. The question says plus 5 volt of potential difference is applied on an electron, the electron gains energy of option A 5 joule, option B 5 electron volt, option C 5 erg, and option D 5 into 10 to the power minus 19 joule. So what will be the correct option? Yes, when a potential difference of plus 5 volt is applied, then the electron will be attracted because it is plus 5 volt and the electron has negative charge. So it will be attracted towards the potential difference region. And due to this potential difference region, the electron will be gaining some energy. So what will be that value of energy? Yes, anyone?
5 electron volt.
Yes. So the correct option, correct answer will be 5 electron volt, because we know that if an electron, suppose, or we can say that if a charge Q is accelerated through a potential difference region of potential difference V, then the energy gained is Q into V. So whether the energy will be gained by that charge particle or it will lose its energy, it will depend upon the charge of that particle and the type of potential through which it is being traveled. So here if you see the electron has negative charge. So here the mass of electron, so here the charge of electron is negative, which is 1.6 into 10 to the power minus 19 coulomb, and V is plus 5 volt. Since the charge of electron is negative and the potential is positive, the electron will be attracted in the potential region and in the process it will gain some energy. So that energy we generally called it as electron volt. So we called 1 electron volt is the energy gained by 1 electron while accelerated in a potential difference of 1 volt. So 1 electron volt, if you see 1 electron volt is 1 volt into 1.6 into 10 to the power minus 19 coulomb. So it is 1.6 into 10 to the power minus 19 joule. So 1 electron volt is 1.6 into 10 to the power minus 19 joule. So the correct so according to this question, since the electron is being accelerated in a potential difference region of 5 volt, then it will be 5 electron volt. So if you the correct option will be obviously option B, which is 5 electron volt. But if all the options are in joule, then what will be the value of 5 electron volt when you convert it to joule? So what is the value of 5 electron volt in terms of joule?
5 into 10 power minus 19 joule.
Yes, so it will be 8 into 10 to the power minus 19 joule. So this is the energy of the electron in terms of joule when it will be accelerated in a potential difference region of potential plus 5 volt. So here the correct option will be option B. So is this clear to all of you, or anyone of you have any doubt? Okay, so we will continue our discussion. So let's go to the next question of the day. Yes. So now this question says a beam of electron is used to bombard gaseous hydrogen. What is the minimum energy in electron volt the electron must have if the first number of the Balmer series corresponding to transition from n is equal to 3 to n is equal to 2 state is to be emitted? So the question says there is a beam of electron which is used to bombard on gaseous hydrogen. So what should be the amount of energy that electron should carry so that it will initiate the transition from n equal to 3 to n equal to 2 state, which corresponds to the first line of Balmer series. The options are option A 1.25 electron volt, option B 1.88 electron volt, option C 2.36 electron volt, and option D 4.05 electron volt. So I'll give you a few minutes to try this. Then after a few minutes, we will discuss. So I will encourage everyone to do on their own and then discuss. So if you are all are responding, then it will be definitely a good interaction class. So anyone calculated? Can anyone tell me what will be the energy of the electron so that there will be a electronic transition from n equal to 3 to n equal to 2 level? Yes, Sushil Chabra, can you hear me? Okay, so let's calculate what will be the energy of the electron which is required for the given transition. So the question says there is a beam of electron which is used to bombard on hydrogen, gaseous hydrogen. So we know in case of hydrogen atom, there is a nucleus in the center and an electron is revolving around the nucleus in different energy levels. So this is n equal to 1, this is n equal to 2, this is n equal to 3. So what are the energy values of those energy levels? For n equal to 1, we have E1 is minus 13.6 electron volt. E2 will be minus 13.6 divided by 2 square. Why? Because if you see the relation for energy of the electron in an orbit is mz square E4 by n square h square epsilon 0 square. So for all these are constants. Z is 1 for hydrogen. We know the electronic charge, we know the mass. Then if you put all these values, this is minus 1 by 8 or is also present. So if we can say that the value of energy of an energy level having quantum number n is direct proportional to 1 by n square. So similarly, if the first energy level has energy minus 13.6 electron volt, so the next energy level for which n equal to 2, for this energy level n equal to 2, so it will be E2, which is minus 13.6 divided by 4. Then for third energy level E3, it will be minus 13.6 divided by 3 square, which corresponds to n equal to 3. So now here what is happening? So a beam of electron is used to bombard on a gaseous hydrogen. So here we will consider that the electron which is coming, it has some energy. So it will collide with the electron which is revolving around the nucleus of an hydrogen atom. So if suppose here we are saying the transition from n equal to 3 to n equal to 2 state. So suppose the electron initially, in case of gaseous hydrogen, the electron was revolving here at n equal to 3. So there was an beam of electron which was again bombarded. So this is the electron beam and this is the electron of the hydrogen atom. So this is hydrogen atom electron. This is the electron beam. So if you see here, the third energy level has energy minus 13.6 divided by 9. Can anyone tell me what will be the value? So if you see, as we go away from the nucleus, the energy is increasing. I mean, since the value is negative, so the energy will decrease. So if you see the difference in energy between E3 and E2, because this is the amount of energy required. So the electron which is at energy level n equal to 3, when the beam of electron is being bombarded, this electron from that beam will give all its energy to the electron which is revolving in n equal to 3 state. And then this electron, since this electron needs to come to this n equal to 2 state, because here there is fast number of Balmer series. So this fast, we know Balmer series corresponds to any transition which occurs from higher state to n equal to 2. So for fast member of Balmer series, the transition will be from n equal to 3 to n equal to 2. So if this electron needs some energy so that it can come from n equal to 3 to n equal to 2, so this energy will be equal to the energy difference between these two energy levels. So if you see the transition, that is delta E, from 3 to 2 will be minus 13.6 divided by 3 square minus of minus 13.6 divided by 2 square. So minus 30, suppose make it plus minus 13.6, then it will be 1 by 4 minus 1 by 9. So if you calculate, it will be coming around 13.6 into 5 by 36. So if you multiply this quantity, it will give you 1.88 electron volt. So this is the amount of energy the electron beam should have, so that when the electron beam is colliding with the hydrogen atom, then the electron in the hydrogen atom, which is in the n equal to 3 state, it will gain the energy 1.88 electron volt and it will come back to n equal to 2 level. So there is transition from n equal to 3 state to n equal to 2 state is to be emitted. So there will be emission from so if the electron collides with the electron of this hydrogen atom, then the transition will occur from n equal to 3 to n equal to 2. So this 1.88 is the energy difference between these two energy levels, E3 and E2. So delta E is nothing but E3 minus E2. So is this clear to all of you? Yes, is this clear to all of you?
Yes, sir.
Okay, so let's go to the next question. This is a good question. The question says, if we arrange the speed in increasing order of the electron in fast Bohr orbit of hydrogen, singly ionized helium, doubly ionized lithium, and triply ionized beryllium using Bohr theory, then which of the following option will be true? So the question is asking us to find that how we can find the relationship between those velocities. So there are four velocity values here given. The velocity of the electron in the fast orbit, that is n equal to 1. For hydrogen it is Vh. For singly ionized helium, it is V, in the subscript it is He. Then for lithium it is Vli, and for beryllium it is Vbe. So there are four velocity values, and all these velocity values corresponds to the velocity or the speed of the electron at the fast Bohr orbit, that is n equals to 1. So which will be the correct order, whether option A or option B, C or option D? So I will let you to solve it, and then after a few minutes we will discuss what will be the correct option of this question. Yes, anyone calculated what will be the correct option? Yes, any answers? Here the question says we need to calculate the speed of the electron in fast Bohr orbit of different atoms using Bohr's theory. So according to Bohr's theory for hydrogen and hydrogen-like atoms, hydrogen-like atom means the atoms which have only one electron. So here if you see, hydrogen has a single electron, singly ionized helium, because helium has two electrons. If it is singly ionized, then it has only one electron again. Then this double ionized lithium has also one electron, and triply ionized beryllium has one electron. So all these atoms which are ionized or hydrogen atom, they all have one electron, and this one electron is orbiting around the surrounding the nucleus in different energy levels. So we can apply here the Bohr's theory of hydrogen atom. So according to Bohr's theory of hydrogen atom, the velocity or speed of electron in an energy level is given by V n z square divided by 2 epsilon 0 n h, where this n corresponds to quantum number n equal to 1 for fast Bohr orbit, which is given in the question. So if you put here n equal to 1, then V1 will be z square by 2 epsilon 0 h, because n equal to 1. So now can anyone tell me in the expression for velocity or speed, which quantity is a variable? Whether epsilon naught is a variable or h is a variable, E or Z. Which quantity is variable in this expression, so that the speed will depend upon that variable and the speed will change when that variable is changing. Once again.
Is it?
Yes, so if you see here, the speed is directly proportional to Z, because all other quantities are constant or we know their values. So for fast Bohr orbit, the speed will be directly proportional to the atomic number. Now, if you see here, for hydrogen, Z equal to 1. So it will be, suppose we take it as V naught. Then for single ionized helium, what is the value? What is the atomic number for helium? It has one electron, but the atomic number is, because it helium, so the velocity will be 2 into V0. V into 2, V0 into 2. Similarly, for lithium double plus, Z equals to 3. So it will be 3V0, because Z is, so V type proportional to Z. Then this beryllium 3 plus, for which Z equal to 4 or atomic number 4, it will be 4V0. So if you see here, the question says we arrange the speed in increasing order. So if we are arranging it in increasing order, then lowest velocity will be of hydrogen, then the helium, then lithium, then beryllium. So what will be the correct option? If you see here, the highest will be of beryllium, then lithium, then helium, then lowest will be of hydrogen. So the correct option is option C, because for all these atoms given, the atomic number is lowest for hydrogen, and since the speed of electron depends upon the value of the atomic number, and the atomic number of hydrogen is 1, while the other atoms have different atomic numbers, and that is greater than 1. So minimum will be that of hydrogen, then with increasing order, then will be of helium, then lithium, then beryllium. So the correct option will be option C. Is this clear to all of you? Yes? Is there any doubt? Anyone?
It's already yes.
Sorry, I can't hear you. Okay, so let's go to the next question. Now the question says, find the recoil speed of hydrogen atom after it emits a photon in going from n equal to 3 to n equal to 1 state. Take Me as the mass of electron, 1836 times Me as the mass of hydrogen atom, R is Rydberg's constant and H is Planck's constant, and C is the speed of light in free space. So when the hydrogen atom emits a photon in going from n equal to 3 to n equal to 1 state, then what will be the recoil speed of the hydrogen atom? The options are RH divided by C. Option B is RS divided by 205 into Me. Then option C is 2065.5 Me. Option D is 1205 into HME. So these are the four options you have. You need to find what will be the recoil speed of hydrogen atom. So why it will recoil? Because it has emitted a photon when it goes from n equal to 3 to n equal to 1 state. So please try this question, then we will discuss. Yes, anyone? What will be the recoil speed? Here we will how we will approach the question. So in order to find the recoil speed of the hydrogen atom, we need to consider the conservation of energy. That is the when the transition is occurring from n equal to 3 to n equal to 1 state, there is a change in energy, and that energy is equivalent to the energy of the photon emitted. So first we will calculate the energy of the photon which is emitted. Then from that energy, we will calculate the momentum of the photon. Then from that, we will calculate the velocity. So if you calculate when the transition is occurring from n equal to 3 to n equal to 1 state, we know we have discussed this several times. En is minus 1 by 8 m z square e fourth by n square h square epsilon 0 square. And for transition between the two levels, the change in energy is delta is equal to r h c, because in options the options are in terms of r, h and c. Also we know the notations, what is r, what is c. So we need to solve the problem in form of this RHC expression. So it will be RHC into 1 by n1 square minus 1 by n2 square. So the energy radiated will be, or energy emitted will be RHC into 1 by 1 square minus 1 by 3 square. Because here the transition is occurring from n equal to 3 to n equal to 1 state. So if you solve it, the energy of the photon you will get RHC 1 minus 1 by 9, which is equals to RHC into 8 by 9. So this is the photon energy. Then if you see, we know in case there is a relationship between energy and momentum. So E is P square C square plus M0 square C to the power 4. If you see here, this M0 is the rest mass, and for photon, the rest mass we know for photon, the rest mass of photon is 0. So this term is 0. Then E will be P into C. C is the velocity of the photon. So that is speed of the light in free space. So the momentum of the photon will be E by C. So here there is a C. So this C will be cancelled out. So momentum will be RH into 8 by 9. So this will be the momentum of the emitted photon. Now, how we will calculate the recoil velocity? So this is the momentum. So using conservation of momentum, this momentum will be equal to the momentum of hydrogen atom, because since the photon is going away from the hydrogen atom with some momentum, with similar momentum, the hydrogen atom will recoil. So we know. So let me add another slide. So if v be the recoil speed of the atom, then we know momentum is m into v, where m is mass of hydrogen atom and v is recoil speed. So this momentum will be equal to the momentum of the emitted photon. So if you equate conservation of momentum, then it will be mass of hydrogen atom into recoil speed will be equal to RH into 8 by 9. And from question we have the mass of hydrogen atom is 1836 times of mass of electron. So it is 1836 into mass of electron into recoil speed equal to RH into 8 by 9. So the recoil speed of electron will be RH into 8 divided by 9 into, sorry, there will be 9 into 1836 into ME. So if you calculate it, it will be RH divided by 8 by 9 into 1836 will be 2065.5 into ME. So this will be the recoil speed of the hydrogen atom, because a photon is emitted due to a transition from n equal to 3 to n equal to 1 state. Since the mass of hydrogen atom is 1836 times ME, so the momentum will be mass of hydrogen atom into velocity, and when we equate that momentum to the momentum of emitted photon, then the recoil speed will be RH by 2065.5 ME. So is this clear to all of you? Yes. Is this clear to all of you, or I need to explain it again? Okay, so let me explain it once again. So the question says there is a hydrogen atom. The hydrogen atom emitted a photon, and that photon, due to the emission of that photon, the electron in that hydrogen atom transited from n equal to 3 to n equal to 1 state. So the difference in energy of the two states will be equal to the energy of the photon emitted. So using the energy relation according to the Bohr's theory, we calculated the difference in energy between the two energy level will be RHC into 8 by 9, because the transition is occurring from n equal to 1 to n equal to 3. So 1 minus 1 by 9 is 8 by 9. So it will be RHC into 8 by 9, where R is Rydberg's constant, H is Planck's constant, and C is the speed of light. So this is the energy of the photon. And if you consider the relations between photon and between the energy and momentum of the photon, then the relativistic relation is given as E equal to P square C square plus M0 square C to the power 4, where M0 is the rest mass energy, P is the moment rest mass, M0 is rest mass, P is the momentum, and C is the speed of light. So for photon, we know the rest mass of photon is 0. So only the energy will be P square C square root over, which will be Pc. So momentum P will be E by C. So C gets cancelled with the numerator and the denominator. Then the momentum is RH into 8 by 9. So this momentum will be equal to the recoil momentum of the hydrogen atom. And we know the momentum is, so one thing here you can say, why here we are using this relativistic relation, but here we are using the simple relation P equals to MB. Here P equal to E by C, but here P equals to MB. So if you see, the relativistic case comes when there is motion of a system which is comparable to the speed of light. So here the motion of the photon is occurring, so the velocity is equal to the speed of light. So we are applying this expression of energy, which consists of both the momentum term and the rest mass energy term. But here, since the mass of mass of hydrogen atom is quite heavy, it is 1836 times, so the recoil speed will be very, very less in comparison to the speed of light. Simply we are using this simple term P equals to MB, momentum equal to mass into velocity. So if you equate these two equations according to the conservation of momentum, the recoil speed will be RH into 8 divided by 9 into 1836 into ME, because the mass of hydrogen atom is given in the question 1836 into mass of electron. So the correct option will be option C. Then next question. The question says, in hydrogen atom, the electron is replaced by a mu1 whose mass is 200 times than that of the electron, and the charge is same as that of the electron. Calculate the ionization energy of it on the basis of Bohr's theory. The options are 13.6 electron volt, option B is 27.2 electron volt, option C is 54.4 electron volt, and option D is 2720 electron volt. Yes, so can anyone tell me which of the option will be correct? Yes, anyone? So here, the ionization energy is nothing but the energy of the ground state of hydrogen atom, but with positive sign, because ionization energy corresponds to the transition from n equal to 1 to n equal to infinity. So if you put n1 equals to 1 and n2 equals to infinity, then your energy will be minus 13.6 1 by n2 square minus 1 by n1 square. It will be minus 13.6 into 1 by infinity minus 1 by 1. It will be simple minus 13.6 into 1 minus 1. It will be 13.6 electron volt. So this 13.6 electron volt is the ionization energy of hydrogen atom, in which an electron is revolving around the nucleus. But here the question says the electron is replaced by a mu1, and the mu1 has mass 200 times that of the electron, and the charge is same. So if you see the relation of energy, En is given by minus 1.8 1 by 8 m z square E4 by n square s square epsilon 0 square. So this here only there is change in mass because charge is same, and all other parameters are same because here E the charge, so charge is same. The for hydrogen atom Z equal to 1. For ionization, this N are irrelevant because only we need to find the total energy from N equal to 1 to N equals to infinity. So N is always 1 here for ionization case. So here the energy is directly proportional to the mass of electron. So here, since the mass is replaced by this mu1, so this is mu1. We can denote it as mu. So this the energy, ionization energy of mu1 will be directly proportional to the mass of mu1, and the mass of mu1 is 200 times than that of the electron. So the ionization energy of mu1 will be 200 times that of ionization energy of hydrogen. So it will be 200 into 13.6 electron volt, which will be 2720 electron volt. So it is around 2.7 keV. So you see, when the electron is being replaced by the mu1, since mu1 has 200 times mass that of the electron, so the required energy to ionize the hydrogen atom will be increased 200 times. So it will be really difficult for ionizing the hydrogen atom if the electron is replaced by mu1. Is this clear to everyone? Yes. Okay, so let's go to the next question. The question says if mu L, this is mu L, L is in the subscript. So if mu L is the magnitude of the orbital magnetic moment of an electron revolving in circular orbit and L is the magnitude of its orbital angular momentum, then what will be the relationship between these two quantities, mu L and L? The options are mu L equals to 2me by L. Option B is mu L equals to EL by 2m. Option C is mu L equal to me by L. And option D is 2m by E into L, where mu L is the orbital magnetic moment and L is the orbital angular momentum. So mu L is the orbital magnetic moment and L is the orbital angular moment. What will be the relationship between these two? Yes, can anyone tell me what will be the relation? Yes, can anyone tell me? Okay, so
Option B.
yes, option.
Option B.
You are saying option B or option D?
Option B, I think so.
Okay, so the correct option will be option B, which is EL by 2m. This
Maybe.
will be the correct option. So now we will calculate. So thank you for your answer. So let's calculate it. We know the the magnetic momentum or magnetic moment is given by mu equals to IA. So when a current is flowing in a cross-sectional area of A, then the magnetic moment is given by I into A. So I is nothing but Q by T and A is the area. So here the electron is revolving around in a circular orbit. So if R is the radius of the circular orbit, then it will be Q by T into 2 pi R, is not it? So suppose this is a circular orbit, it has radius R and an electron is revolving. So there is a current I. So mu will be I into A. So now let's first calculate the time period. So what will be the time period? The time period T will be circumference divided by speed. So circumference is 2 pi R and speed is V. Is not it? So if you calculate, what will be the value of mu? This is Q. Q means here for electron we can put it as E divided by T is 2 pi R by V into 2 pi R. Sorry, here the area will not be 2 pi R. Circumference is 2 pi R. Sorry. So here it is not 2 pi R. It is pi R square. It will be pi R square. And 2 pi R is the circumference. So it will be E by 2 pi r by v into pi r square. So it will be EV divided by EB into R, because 1 R will get cancelled out. I will get cancelled out. So EB R divided by 2. So this is the value of mu L. So when an electron is revolving in a circular orbit, the magnetic moment it will produce will be EVR by 2, where V is the speed of the electron in that orbit and R is the radius of that orbit. Now here L is also given. L is the magnitude of its orbital angular momentum. We know L is, according to Bohr's theory, L is m v into r. So linear momentum into radius of a circular orbit is angular momentum. So L is mvr. So this is second equation. This is first equation. So if you put the value of vr, it will be L by m. So if you put here the value of vr, slide. So we have mu L equals to EVR by 2, which is option 1, and L equals to MVR, which is option 2. Now this equation 2 will give us VR equals to L by M. If you put this value of VR here, it will be E by 2 into L by M. So mu L will be EL divided by 2M. So the correct option will be option B, EL divided by 2M. I hope this is clear to all of you. Then we will proceed towards the next question. Is it?
Yes, sir.
Okay, so let's solve the next question. And the question says, if H is the Planck's constant, E is the charge of electron, and M is the mass of electron, then its magnetic moment when it is in fourth orbit. So this question is somehow related to the last question. In last question, what we found? Mu L and L relation. So using those expressions, we will calculate what will be the magnetic moment of the electron in fourth orbit. Yes. Option A is He by 4 pi m by 2 pi m, 4He by 5m, and He by pi m. So these are four options. So can anyone tell me what will be the magnetic moment when it is in fourth orbit? That is n equals to 4 according to Bohr's model.
Option B, I think so, sir.
Once again.
Option B, maybe.
Yes, option D, it will be He into He divided by pi m. So how did you approach it? How to solve it? Can you tell me?
Sir, I just guessed. I think it could be.
Yes, the
Uh,
option D is correct option. This will be the correct option, but how you proceed with the problem? Because here if you see, there is a relation mu L equals to EL by 2M.
2m.
So here the relationship in all the options there was mu L and L, but here there is no L
No
here.
L here.
We need to find out the value of mu L, but there is no L. So
L.
we need to find the value of L for fourth orbit so that we can use that value of angular momentum and we use the value to calculate the magnetic moment. So what will we do?
L equals
So
MVR.
if you see here, according to, if you remember, there are one of the postulates of Bohr is quantization of angular momentum, and he said that if an electron is revolving in an energy level of say n equal, so the if the quantum number is n, then the angular momentum will be L, which is equal to mvr, will be n h by 2 pi. Is not it? This is one of the postulates of Bohr.
NH.
So
Yes.
if you put the value of L equals to nh by 2 pi, we had in the we had the relations mu L equal to EL by 2m. So from previous question, we have mu L equal to EL by 2m.
Two.
So for fourth level, nh by 2 pi for n equal to 4 will be 2h by pi. Is not it? Because here will be 4h by 2 pi, which will be 2h by pi. So simply you put the value of L here, it will be E by 2m into 2h by pi. So 2 gets cancelled out. Mu L will be EH by pi m. So this is the expression for magnetic moment in fourth orbit according to Bohr's theory. So the correct option will be option D, EH by pi m. Is this clear to everyone?
Yes, sir.
I think only one student is responding. What about others? I think this is an interaction session, so it will be better if you interact with me. If you have any doubts, you can ask about me. Ask to me about it. So it will be basically more a interaction session. But if you don't ask anything, then I will come and will solve these questions one by one. Then I will complete the session. Then there will be no gain of you. Okay, so let's go to the next question. Now this question says, instead of circular orbit, the concept of elliptical orbit in Bohr model was introduced by, and the options are. So I request all participants to mute themselves and unmute only when you are trying to speak something or you are having some doubt or you are responding to my queries. Unless you mute yourselves. So the question says, instead of circular orbit, the concept of elliptical orbit in Bohr model was introduced by. Here this is option A. Option A is Max Planck, option B is Sommerfeld, option C is Maxwell, and option D is none of the above. Yes. Yes, exactly. So initially Bohr said that the energy levels in which the electron is evolving are circular in shape, but according to the corrections given by Sommerfeld, the energy levels were not circular and it was elliptical. So not all energy levels are circular. In the upcoming questions, we will discuss about these concepts. So this concept was basically introduced by Sommerfeld. So the correct option will be option B. Then question 8. The number of degrees of freedom for the motion in elliptical orbit is 0, 1, 2, or 3.
Sir, I think it's 0. Maybe.
Not if
Not
there is
0.
a motion, if there is a motion, then there is a degrees of freedom.
Okay, degrees of freedom is nothing but difference of
So,
number of coordinates and number
okay,
of
so
constraints,
degrees of
right?
freedom is basically the number of coordinates using which you can explain the motion of that system.
Okay.
So we say if a substance is moving in space, then it has 3 degrees of freedom. If it is moving in a plane, which is a 2-dimensional space,
Two
it has
dimensions,
2 degrees
2
of
degrees
freedom.
of freedom.
If the object is moving in a straight line, then it has only 1 degree of freedom.
1 degree of freedom.
So that degrees of freedom, suppose, so this degrees of freedom is some coordinates. So like there is a space. Suppose this is a space. It looks like 2D, but assume it is a 3D space. So suppose the object is here and we define an origin here. So the object is at some distance from this origin. So in order to define this distance, we will need some coordinates of that objects. So it will be some x, then y, then z. Then these are the coordinates and these are the degrees of freedom. So an object which is moving in space, it has 3 degrees of freedom. Similarly, in case of a plane, so it suppose this is origin, so it is at this point. So if this is x-axis and this is y-axis, this point will be xy. So we need 2 coordinates or 2 variables which are changing. If you only say x, then we can't say the position with respect to y-axis. So we always need 2 coordinates when we are explaining some motion which is occurring in a 2-dimensional space, that is a plane. So similarly, in case of 3-dimensional also, so there will be 3 coordinates which are x, y, and z. So, but here the question says what will be the number of degrees of freedom for the motion in elliptical orbit. So we will talk more about the degrees of freedom. So can anyone tell me, suppose there is a substance. Let us take the example of one hydrogen molecule. So this is one hydrogen atom. This is another hydrogen atom, and they are bonded with the bond. So can anyone tell me what will be the degrees of freedom of this hydrogen molecule?
1.
No, not one. If you see, like here I said, obviously these are in space. So when the object is moving in space, we need 3 coordinates. So for this hydrogen atom, we will need x1, y1, z1, 3 coordinates.
Degrees of
Isn't it?
freedom is 2.
No, not 2. Wait a minute. I'll be back in a few seconds. So yes, sorry for the interruption. So if we are talking about the hydrogen molecule, so for hydrogen, one hydrogen atom, this is x1, y1, z1. So these are 3. But similarly, there is second hydrogen atom. This also we need other three coordinates to define x2, y2 and z2. This is not it. So there are 6 coordinates we need to define. But here, if you see, the two hydrogen atoms are always bonded with each other. So there is a fixed distance between these two. Suppose this distance is bond length b. So this is a constant of their motion. So one hydrogen atom is moving in. So all these two, sorry, I mean to say, if the system is in space, the one hydrogen atom has 3 coordinates, the other hydrogen atom have another 3 coordinates. But when they move, the distance between these two hydrogen atom always remains same because they are in a molecule. So here, this bond length B will act as a constraint. So since that the two hydrogen atoms are bonded, so their motions will be constrained, and this is total. We have total number of coordinates 6. Then there is one condition, that is the distance between the two hydrogen atom is fixed. So there will be one. This is one is known as constraint equation. So this is constraint. Then it will be 5. So the number of degrees of freedom a diatomic molecule has, it is 5. So similarly, can anyone tell me, suppose there are 3 balls and they are connected like this. Can anyone tell me what will be the degrees of freedom of this system? This is moving in space.
6.
9.
No, not 9. I just explained.
Sir, it's 6 because there are the 3 particles, right?
Exactly.
So
So
each
here
particle
there are
will be
3
having 3
constraints.
coordinates.
There is one constraint. This is another constraint. This is another constraint. So there are 3 constraints. So it
And
has
3 particles.
3 coordinates. So it will be 3 into
9
3.
minus
That is 9 minus 3. It
minus
will be
3.
6. So this is one example. This is another example. So similarly, if you are talking in a plane, it can move in x direction, it can move in y direction. But since it's a plane, it can move in z direction. Can it move? It can't move.
No.
So that's why the z is not defined here. So there are only 2 coordinates using which we can describe the motion. Suppose the particle is here, we can say the coordinate is x1, y1. We don't need z coordinate. Z is always fixed, that is z equal to 0. So similarly, if there is a circular motion, so first we will talk about circular motion, then we will go to ellipse. So suppose it is a circle and the object is moving on the circumference of the circle. So this is the origin. So if at any moment I will ask someone what informations you can give if the body is moving in a circle. So in terms of any quantities, he or she will give me information. So what are those quantities? Suppose like in space or in a plane, there are 2 coordinates x and y. So in a circle, there will be 2 coordinates. What are they? One is obviously the radius of the circle r, and another, if we draw a line here, like here, this xy is nothing but the distance with the origin. So here it is origin. So now here we will assume that this is a center. Then we will draw a horizontal line. Then this will be the angle theta. So here the coordinate is given by r and theta. So basically this is a polar coordinate system. Plane, we call it as plane polar coordinate. This is 2-dimensional orthogonal coordinate. This is two-dimensional plane polar coordinate. So in this coordinate there are 2 degrees of freedom, r and theta. So now if you see, when the motion is circular, r is always fixed, is not it? If I will tell you the particle is moving in a circumference of the circle having radius 5 centimeter. So we don't need the value of r because it will always will be moving at r equal to 5 centimeter. So we only need the value of theta. So someone will say it is at theta 120 degrees. So I will know the object is here and the angle theta is 120 degrees. So when the object is moving in a circle, then the only coordinate required is theta because the value of the radius r is constant always throughout the motion. But if you consider an ellipse, then it has both major radius and minor radius. So these are the two foci. Suppose the object is here. So there is a distance r and there is angle theta. Then there is another, suppose the object is here. So there is distance r1 and this angle is theta 1. So here r is not constant. Can you understand? Here r is not constant. So whenever the object is moving in an elliptical orbit, we need two coordinates. We need r. R is nothing but the distance from a fixed point. We can consider this as the focus. This focus, we can consider this focus like here we consider this origin. Here this focus, the center act as a fixed point or reference point. Here this origin act as a reference point. Here this focus act as a reference point. So here, since the distance from the here the distance is not changing throughout the motion, only the angle is changing. So here both the distance and angle both are changing when the object is moving in an elliptical orbit. So here there are two variables which are independent and we need both the variables in order to explain the motion of the particle. So here the correct option will be yes. What will be the correct option? Motion in elliptical orbit.
2.
Yes. So it will be option C. So if you talk about a simple pendulum, you know, there is a simple pendulum is simply there is a fixed point here, then there is a string and there is a pendulum here. So if you move the pendulum and the pendulum is doing the simple harmonic oscillation, basically the motion is called a simple harmonic oscillation. So at any moment of time, since this is fixed, the string, the length of the string, if you assume that the spring is unextensible, so the length of the spring is always fixed. So this is x, which is fixed. So this is the line we draw. Then suppose it is at here, so it will be only angle. So for simple harmonic motion, there is only one coordinate, theta. So for different motions, we have different degrees of freedoms or different coordinates. And if there are constraints, the motion or the degrees of freedom of that system is reduced due to the presence of those constraints. Is this clear to everyone?
Yes, sir.
Yes, sir.
So you all must have heard about classical mechanics. Now, you are from which background? Are you doing BSc or you are in MSc?
I'm doing MSc.
So obviously you must have heard of classical mechanics, those degrees of freedoms. Then there are also if you talk about constraints, then according to their time dependent, then constraints are also classified into different types. So there is Lagrangian, Hamiltonian. So all of these, there are many things. So if you want to read, you can prefer any standard book and you read about these degrees of freedom. Also there, these types of question also comes in GATE net also. There's a system and you need to find out the degrees of freedom of that system, the number of degrees of freedom. Okay, so we'll go to the next question. Now, I was talking before, sometime I was talking about, we will discuss more about the Sommerfeld theory and the introduction of the elliptical orbit. So now this is the question. The question says, according to Sommerfeld's theory, if A and B are lengths of semi-major and semi-minor axis, then where k and n are azimuthal and total quantum numbers respectively, then which of the following relations is true? So this is based on Sommerfeld's theory. So try this question. I'll give you a few minutes, then we will discuss which of the relation is correct according to the Sommerfeld's theory. So yes, can anyone tell me? So can anyone tell me what will be the relationship between the semi-major and semi-minor axis? According to Sommerfeld's theory, if you see, the semi-major axis is given by A equals to n square by z A0 and B equals to n k by z A0. So if you compare these two, B by A will be how much? Will be B by equals to K by N, is not it? So if you these will cancel out, these will cancel out, only this one N will cancel out. So B by A will be K by N. So this is the relation. So B by A is equal to K by N, B by A equals to K by N. So it will give Bn equals to AK. So this is the correct option. That is option C. So the correct option will be option C, Bn equals to AK. Is this clear to everyone?
Yes.
Okay, so let's go to the next question. So now we introduced from the beginning, we were only discussing about only a single quantum number, which was n. But in Sommerfeld's theory, there was a new quantum number that was introduced, that was known as k, the azimuthal quantum number, and there is another n r is the radial quantum number. So according to the Sommerfeld's theory, the total quantum number n is radial plus azimuthal. We know the values of n is 1, 2, 3, 4 like that. So corresponding to these, there will be these values nr plus k. So nr will be having different values and k will be having different values. So the question is about that. If k is azimuthal quantum number and nr is the radial quantum number, then which of the following is true? Option A, k will be having values 0, 1, 2, 3, 4. nr will be 0, 1, 2, 3, 4. K will be having 0, 1, 2, 3, 4, or NR is starting from 1, 2, 3, 4. Or another option is option C. K has values 1, 2, 3, 4 up to N, and NR has values 1, 2, 3, 4. And again, the option fourth is all of the above options are wrong. So can anyone tell me what are the possible values of NR and K, where NR is the radial quantum number and K is the azimuthal quantum number?
Option C, sir.
Sorry,
Option C, sir.
option C you are saying. No, option C. No, option C won't be true because if you see, it is clear that K won't be having zero values. Once again, I request everyone to mute themselves. There is some unnecessary noise which is coming. So if you see, we said B equals to N K by Z A0 and A equals to N square A0. So K can never be zero because when K equal to 0, B will be 0. So there will be only a single point. So K will not be 0. So these options are not applicable, or these options are not true. But here if you see, this NR is not N. This N is NR plus K. So if K starts from 1 and NR starts from 1. So suppose the lowest value of K is 1 and the lowest value of NR is 1. So since N is NR plus K, the lowest value of N will be how much? Plus 1, 2. But it is wrong. N always starts from 1. Just I have mentioned here. the principal quantum number n starts from 1. So since k can't be 0, nr can be 0. So the actual correct option here will be option D. None of the above is correct. But actual the k values will be, k can take values from 1, 2, 3, 4 like that. And nr will take values from 0, 1, 2, 3, 4 like this. So this will be the correct combination of the values of k and nr, because these satisfy the relation of total quantum number equals to nr plus k, where nr is the radial quantum number, and since nr can be 0, k can't be 0. So the overall sum of the quantum numbers is always greater than or equal to 1, and this n equal to 1 corresponds to the first energy level. So the principal quantum number n can never be 0. So option D will be the correct option. Then the last question. This question says, considering the fine structure of hydrogen atom, how many discrete spectral lines are possible for transition from n equal to 3 to n equal to 2? So these are the four options: 1, 2, 3, and 4. So now, initially in case of Bohr, there was only n. N had values 1, 2, 3, 4 up to. But in case of Sommerfeld, there was a new quantum number introduced, that was k. So k, as we all just talked about, k will also start from 1, 2, 3, 4 like that. But the maximum value of k is n. So for n equals to 1, k will be 1. So up to n. This n corresponds to this principal quantum. So for n equals to 2, k will start from 1 to n, that is 1 and 2. For n equals to 3, k will be 1, 2, 3. Then for n equal to 4, k has 1, 2, 3, 4, that is 4 values. So like before, only when Bohr gave the postulate, n equal to 3 was a single line or single level, n equal to 2 was a single level. But if you consider these modifications according to Bohr-Sommerfeld theory, then n equal to 2 will be again divided into two energy levels, because corresponding to n equal to 2, there is another quantum number that we found, and this has two values. So this n equals to 2. So this was the two energy levels. This was n equal to 2, and this was n equals to 3. So according to this was according to Bohr, but when fine structure came into picture, then there is another quantum number introduced, and this quantum number k resulted in the splitting of the general levels in two parts. So one was n2 k1, then n2 k2. Then the similarly n3 will be divided. So for n3, there are three k values: k equal to 1, k equal to 2, k equal to 3. So now I am not going about the values which will be lying below, which will be lying above. No, we will discuss it in details in future sessions. But simply, if you see, now these two energy levels, there was only a single transition n equal to 3 to n equal to 2. But since there are more than one energy levels for n equal to 3 and n equal to 2, so obviously there will be more transitions. And the transition rule, which is the transitions are governed by a rule which is called a selection rule, and that rule says delta k will be plus minus 1. So the transition will be occurring such that delta k will be always plus minus 1. So if you see here, from k equal to 1, if the transition is occurring, then it can occur only to n equal to 2 states, that is k equal to 1 and k equal to 2. So k equal to 1 to k equal to 1 is not possible, because delta k will be 0, k minus k 1 minus 1 will be 0. So this k equals to 1 to k equal to 1 is not allowed. Similarly, k equal to 2 to k equal to 2 is not allowed, because both have same value of k. But delta k, we need delta k is equal to plus minus 1, and 0 is not allowed. So if you actually draw the um, allow transitions, then it will be, suppose there are three labels. This corresponds to n equal to 3, k equal to 1, n equal to 3, k equals to 2, n equals to 3, k equals to 3. And then these are two labels, n equal to 2, k equal to 1, n equal to 2, k equal to 1. Sorry, k equal to 2. So from k equal to 1, k equal to 1 will not be allowed. So it will be allowed from k equal to 1 to k equal to 2. Then from k equal to 1, now k equal to 2, k equal to 2 to k equal to 1 will be allowed. Then similarly from n equal to 3, n equal to 3 to n equal to k equal to 3 to k equal to 1 is not allowed because 3 minus 2 is 1, it is allowed, but 3 minus 1 is 2, it is not allowed. So from this 3, it will only transit to k equal to 2. So these are the three transitions that are allowed, and these are the three transitions that are not allowed. These are the two transitions of simply again, if you see from k equal to 3 to k equal to 1 is again not allowed because as I said, the change in k, that is delta k, will be 3 minus 1 equals to 2. So only the three transitions are allowed. So the correct option will be option C, that is in case of fine structure from n equal to 3 to n equal to 2. If you see, you see when there is only single quantum number, so the transition between n equal to 3 to n equal to 2, we are assuming that there will be a single transition or single line. But here, if you see, if you assume the fine structure, then the single component is being splitted into three components. So this is basically the fine structure of hydrogen atom. So we will discuss about it in more details in future interaction sessions. As we move forward in the course, we will discuss more and more concepts. So I hope I have discussed these problems and I might have solved your doubts regarding these problems. So thank you all for joining in today's interaction session. So is there any doubt regarding this session today or any question you want to ask? Yes. Okay, so if you don't have any doubt, then we can conclude the interaction session. So in the next session, next Friday, we'll discuss some new problems which will be based on week 4 or week 4 of the this course, atomic and molecular physics. We will discuss more about those fine structure splitting, and then we'll discuss more about the relativistic corrections and other concepts which will be covered in the course content. So I would like to thank you all again for joining in today's session. That's it.
Thank you, sir.
Okay.
Thank you.
Right.